Our intervention takes place at the Woodland dining facility in the Forest Quadrangle at Indiana University. Our aim was to use the resources learned in class on behavioral intervention techniques to try to reduce bottled water consumption on campus. Energy used to produce bottled water is 2,000 times that required to make tap water. Let us now watch as we observe a student in his natural habitat. Matthew walks over to the water cooler. Upon arrival at the cooler, he sees a sign pointing to the Coke machine. The sign, which uses conjunctive focus, directs Matthew to the virtually free water he could get from the nearby machine. We measured the success of our experiment by collecting daily sales data per customer from the register. The research design consisted of a pre-intervention period of 2 weeks and a post-intervention period for 2 weeks for which we collected our data. As Matthew goes to check out, he's excited at the prospect of the reduced cost of his environmentally conscious decision.
Much will that be? 9 cents.
Now Matthew walks over to the nearest gathering table and sits down near one of his peers.
Hey.
The girl glances over and sees that her Dasani water bottle cost much more in comparison to Matthew's more environmentally focused decision. As the girl storms away, Matthew notices the table tent, our intervention B, that uses a combination of a descriptive norm coupled with an injunctive norm to indicate what other consumers thought of bottled water and give direction on what the correct mind frame is. Finally, we used both intervention techniques to direct to our informative website. Matthew returns home, intrigued by what he saw at Woodland, and becomes entranced in the website. This website teaches Matthew the importance of the intervention. We will now turn to the experimenters to explain their process.
Through a study published by the Pacific Institute, we learned that bottled water from manufacturing to point of sale has an average embedded energy use of 0.73 kilowatt hours per liter volume. Woodland Dining Facility sells 2 brands of bottled water, the first of which is Dasani, sold in a half-liter or 16.9-ounce bottle. In order to calculate the energy use associated with each bottle of Dasani water, we carried out ounce-to-liter unit conversions and applied the 0.73 kilowatt figure mentioned just above. This results in a total of 0.365 kilowatt hours of energy used per bottle of Dasani water sold. Second, there is the Smart Water brand sold in a larger 20-ounce bottle. Using the same calculation procedure, we arrived at a figure of 0.432 kilowatt hours per bottle. Altogether, Woodland sold an average of 4,558 bottles of water per week prior to the intervention. This amounts to a total embedded energy use of 1,809 kilowatt hours. This is equivalent to roughly double an average American home's use of electricity in a given month. Overall, we found that the post-intervention time period had a reduction of about 200 bottles of water per week. Due to fluctuations in the number of customers per day and an excluded day of data due to Easter, we used a regression analysis to more accurately test our hypothesis, using a dummy variable for time after the intervention was implemented. Unfortunately, we actually found that this variable increased the number of water bottles consumed per day, but this finding was not statistically significant. In short, we have no hard evidence of the impacts of our intervention.
Limitations to this project include lack of a control group, which would help determine if some of our results were due to factors like weather or time of the semester. In our results, we saw a spike in water bottle consumption after spring break, and we hypothesized that this was due to students stocking up and replenishing supplies in their dorm room. Without a control, we were unable to account for the reason for this spike. There could also be psychological reasons that students want to drink more bottled water after spring break, like trying to be healthier after a vacation. Future iterations of this experiment could be longer in duration, have a control group, and have a social media push to increase visibility of the website. Additionally, the rollout of the second phase of the experiment, which is not yet included in this project, includes a public commitment component to the website. Results coming May 2025.